Alright, this video is about evaluating a definite integral using integration by substitution. So the example we're going to do today is pictured here. We're going to evaluate the definite integral of x e to the 2x squared dx from 0 to 4. And there's something that you should know especially when you're integrating with substitution, is that it's implicit in this notation here, integrating from 0 to 4, that since this says dx, we are integrating from x equals 0 to x equals 4. And so we don't normally write that because it's implied that we're doing this since it says dx here, since we're integrating with respect to x. But I'm going to state that explicitly here because it's going to be relevant in a moment. So what is the overall strategy? Well, we're going to use the fundamental theorem of calculus by finding an antiderivative for this function. And then we're going to ignore constants of integration and evaluate that function at these endpoints here. And that's how we get the value of this definite integral. Okay, so first of all, we want to integrate this by substitution because what I see here is I see a function and something that looks like its derivative. That function is 2x squared. So I see that function and I think the derivative of this is 4x, and I don't see 4x anywhere, but I see something that's off by just a multiple of a constant. So I see an x here, and I think if I just multiply that by a number, it could be 4x, and that's close enough in this case. So more explicitly, I identify the substitution that I want to make. So I want to let u equal 2x squared. And then what happens? If I calculate du dx, then I get 2 times 2, which is 4. And then I reduce the power by 1, so I get 4x. And another way of saying this is if I multiply, quote unquote, by dx and then divide by 4x, I can also say that this means that dx equals du over 4x. And so the idea with integration by substitution is that if I make these substitutions right here, this one for u and this one for dx, that I get something that I know how to integrate. I get something that I know an antiderivative for. So let's go ahead and make these substitutions. So I get the integral from x equals 0 to x equals 4. And I don't do anything with the x yet. I still have my x. And then here's my u, so I have e to the u there. And my dx is du over 4x. So this is du over 4x. And here's the good thing that happens is that this x cancels with this x. That's what I meant when I said this kind of looks enough like 4x for the x's to cancel, and then I end up with something that I can integrate. So in other words, what do I have here? If I cancel the x's with one another, and I'm going to treat this 4 in the denominator as a 1/4, and constants can move through integral signs. So I'm going to bring it out front. So I get 1/4 times the integral from x equals 0 to x equals 4 of e to the u du. Now notice, this is an easy integral to do. The integral of e to the u du is e to the u itself. And now you have two options here. And this is why I wanted to be explicit about the limits of integration, how these limits of integration are in x. Now, one of your options is that if you want, you can just change these limits of integration in x to limits of integration in u. In other words, you can substitute with the limits of integration as well. So how do I do that? Well, I realize that when x equals 0, if I look at my definition of u up here, if x equals 0, u equals 0. Let me write that down. X equals 0 means that u equals 0. So I can substitute with my limits as well. My 1/4 stays, and I have the integral from u equals 0. And what about when x equals 4? Well, when x equals 4, so x equals 4 means that u equals what? Well, u equals 4 squared times 2. 4 squared is 16, so u equals 32. So I can put at the top here u equals 32. And my integrand stays the same, e to the u du. Now, what I have here is I've eliminated x from this integral entirely. I can just evaluate this integral by itself. So let me go ahead and do that, and then I'll show you the other method. So I have 1/4 times, what is the antiderivative, or an antiderivative of e to the u? It's just e to the u. And then when I evaluate at my endpoints, according to the fundamental theorem of calculus, I'm going from u equals 0 to u equals 4. And so I evaluate the top limit first. So I have 1/4 times, and I'm not going to use a decimal approximation here. You can do this on your calculator. My answer will be exact. We're going to do this entirely by hand. So I get u to the 4, or I'm sorry, this is not supposed to be 4. This is supposed to be u equals 32. So I get e to the 32 because that's the top limit right here. That came from right here. Sorry for the mistake. And then minus this evaluated the bottom limit. So that's u equals 0, so e to the 0 is 1. And then I'm finished. This is the number that I was looking for. So on the other hand, this was option 1. Option 2 is that if you want, you can just leave the limits in x. Now let's see how we do that. So I'm going to take this and start again down here to do my alternate method. My alternate method is that I just integrate, but I keep the limits in x. So I still have my 1/4, and I integrate. I get e to the u again, of course, because that's the antiderivative of e to the u du. And then what do I get? I still have my limits in x equals 0 to x equals 4. Now at this point, what I would do to do this a little differently is just substitute u back in, because my limits are in x here, but this is in terms of u. I want this in terms of x. So I get 1/4 times, what was u? It's 2x squared. So I get e to the 2x squared. And then my limits are still in x. So I get x equals 0 to x equals 4. And now, just as before, just as I did here, I fill them in. I evaluate at the endpoints, in other words. So I get 1/4. And what do I get for the first one? Well, I get x equals 4, so I get x to the squared is 16 times 2 is 32. So I get e to the 32. And then minus this function evaluated at the lower endpoint, or the left endpoint, which is x equals 0, so I get e to the 2 times 0 squared, which is e to the 0, which is 1. So I get the same answer both ways. It's just a matter of personal preference of how you would do this. And that concludes our video.